Hi, I'm Sherjeel Shabih. I'm a PhD student at Professor Christoph's lab at Humboldt University. I'm working with FAIRmat as a local domain expert. And for a year and a half approximately, I've been working with eLabFTW and trying to see how it fits our lab's needs. So I prepared this small presentation, and this is where I'll talk about how one could integrate eLabFTW and NOMAD. So the contents of this talk would be first, how you could transfer experiments from eLabFTW to NOMAD, in case you already have an installation and you would like to migrate all that data. Um, Also, I will talk about the features that we needed to add to eLabFTW to make our lives a bit easier for our lab to fit our workflows better. Um, and then we ran into some design issues in terms of how to continue development, and I'll also talk about them. And then now, because a lot of ELN features have been added to NOMAD, we're kind of working on a workflow with NOMAD and trying to see if we can just work the same way we did with eLabFTW from now with NOMAD. So talking about transferring experiments, right? So I believe that some digital data is still better than no digital data, especially if it's all collected on one server or one location. It's much easier for one person to then move this data instead of running around and asking everyone, hey, can I have your experiment data so I can place into a new database system? So if it's collected once in one database, it's much easier to migrate it. And this is what I'll show in this live demo, how to get your experiment data from eLabFTW into a Jupyter notebook, and then how to re-upload that to something like NOMAD, a more structured database system. So I have this notebook that walks you through the steps. So let's say, like a lot of you mentioned how you could get API keys from eLabFTW and whatnot. So I will show that as well. What you need to do is first you can log into your eLabFTW instance, and then all users have this user panel tab. And if you go to the user panel, then you can come to API keys here and just create an API key with the name. Let's call it API key, and you can set its permission. So whether it can read the experiments that you have access to, or also write to those experiments. That means uploading files and whatnot. Then you click this generate an API key, and it will output an API key that you can store somewhere like your Jupyter notebook, where you could reuse it. So here I have generated one. This is on my local instance. So even if you were to copy this, you won't have access to my data. But just for demonstration purposes, I have an experiment here from our lab. It's a tychography experiment, and we have some images pasted from the reconstruction, and we've attached some files, some metadata associated with it, and a 3D coordinate file that displays the structure of the material we worked with. And all of this was done in eLabFTW. And now if you would like to bring this back to NOMAD, we can access this through the API. So here I have this API key already. I just made this convenient Jupyter notebook where I can paste it and send it around if anyone needs to use this. And then in this tab, for example, instead of just using the ID at the end, I just make it a bit easier. I say, okay, you can just copy paste your URL from the browser window here and paste it into this notebook, and it will fetch out the ID or any other knowledge that it needs, like the domain name where the API endpoints are. So this Jupyter notebook really just fetches out the information from this URL. And then so I'll just run this once more. And then once we have this data, it's now available in this JSON object using a request. If you would like to see what this really looks like, we could do a xp_data here. And as you see, it's the same title. It also gives us the date, the text in the rich text editor, and such stuff. So you have all your data accessible. And now, once you have this data in a structured way, you can upload it back to Nomad. Now, Nomad's authentication system works a bit differently. It uses Keycloak, and you get a 24-hour token based on your user ID and password. So in this notebook, I've made these convenient functions where if you enter your username and if you enter your password, this notebook actually finds all the information it needs again from a URL. Maybe I'll need to copy this one here. Sorry about that. Yeah. So it finds the upload ID that you need to go to. I'll explain how to get this URL in a bit. And then it fetches the authentication token so that you can securely communicate to to Nomad and publish your data. So only the user that has access to this upload can upload new data and just not anyone who has access to this instance. So to get this upload URL with this upload ID, you can actually come to the upload section of Nomad, create a new upload. And when you do this, there is a new entry down here. And if you go into this entry, you can see that there is a URL up here, which gives you your upload ID, and it also lists which domain you're accessing this instance of Nomad at. So just using this URL, you get most of the information you need. But Nomad also provides this API button on most of its pages where you can actually see how this web browser client accesses all your data. So you can really use the same features that Nomad's client is providing. And I really like this, that for advanced users, you can come here and see exactly what kind of data is being served from the Nomad server. But you don't need to worry about that. Once you have your URL, you can go back to this notebook and fetch all the data, get the access token. And here you see the same object here, EXP data. I kind of reformat it for and extract the rich text information from eLabFTW. And I place it in a new JSON object that describes how it should be placed in Nomad. And then I can hit upload, and it should recreate that same data that we saw in eLabFTW within Nomad. So it's the same kind of rich construction images and the rich text, the same amount of data, but now it's backed by a schema that defines what this data means. Yeah, this is it for the live demo. I hope this gives you an insight on how you could transfer data from one database system to another once you have them in some sort of digital format. So initially, when we started using eLabFTW, there were like some features like the rich text editor and whatnot, but a lot of things that we really expected to have or were already in our workflow didn't really exist. So our lab tried to implement these ourselves because eLabFTW is really free and open source, so it's easy to do that. So the initial things we added were the drag and drop images option you see. So initially eLabFTW didn't have this, and we're really used to taking screenshots of things that we've acquired, like data in our acquisition software, and pasting it into OneNote. So it really recreated that kind of workflow. But we also needed to upload metadata captured by the acquisition software, and placing that into rich text is possible. But if anyone who's editing the experiment by mistake misspells the field name or erases a pre-generated field name, we lose our parsing abilities, and then we have to really check which experiment has that bug and fix it and whatnot. But with something like JSON, it really helps give some structure. So this is another mod we added. Then we wanted to be able to view yield spectra within eLabFTW. So we added a plotting utility that lets you see .msa files with counts on the x-axis and energy on the, counts on the y-axis and energy on the x-axis. And you can see that plot nicely in eLabFTW. On top of that, I know this question came up after Pepe's presentation. But this is something we had to actually add to eLabFTW. It supported files up to around 4 gigs or something, and it kind of relies on the system RAM, and you really can't upload files that are bigger than um, what your RAM is on the installed system, or there's also a timeout problem. So like the bandwidth, so like the amount of time that it takes from your client PCs to really send the data over. If it's really big, there's a time limitation and the connection cuts out. So these kind of things had to be worked in. So we added support for that. And then we also do not want to like duplicate data. So once we have it in eLabFTW, we don't want to move it around again, where we have 10 different versions of the same data in our labs between our collaborators, where someone has maybe ran some kind of analysis with some parameters and cleaned it up a bit. So we wanted to just, once that it's on the server, we don't want to really move it around. And that's why we added support for launching Jupyter notebooks or our in-house tools directly on the server. On top of that, in the talks yesterday, we mentioned that we added support for eLabFTW in our acquisition software. This was also done through the API. So whenever we collect data at our microscope, we can upload that data directly to eLabFTW with a single click. But I will not demonstrate that today. I don't have it installed on my system, but we do use it in our lab, and it works rather well. So obviously, this is a simple example of what this feature does. Is really you drag and drop an image into the rich text editor, and it properly uploads it, and you can store information like even Pepe showed. If there's a small screenshot of some data that you would like to quickly place, or like a graph, you can easily do that. On top of that, this is an example of the metadata that we capture from one of our sensors from Dectris. And this is not really easy to place in the rich text, because if someone by mistake erases this last S here or misspells calibrations somehow, any automated system that runs over it would fail. While in a JSON format, you really can edit the fields on the side. And this has led to actually the HTML web elements you saw when Pepe was demonstrating in the last talk, where you can have your sample ID, owner, and dropdowns and whatnot. This also comes from this kind of structure. And yeah, this is the Spectra Viewer we added to eLabFTW. So this shows an EEL spectrum from an MSA file. So if you upload an MSA file to eLabFTW, it would let you click a link that demonstrates, that plots it just like this. And yeah, so this is a major problem that we face, where we're creating data in like magnitudes of 10 gigs or even more. And a lot of users in my lab had a problem where either their home connections wouldn't be fast enough and it would time out, or the RAM on our server, even though it's quite a large server, but still the RAM would fail. So I implemented this new way to upload by using more modern techniques, where it kind of streams the data instead of really allocating it into RAM and then copying it. But I guess I wouldn't get into the technical details. It just means that you can upload relatively larger data than what eLabFTW was doing before. And now this this idea of launching Jupyter notebooks or any tools that we are used to using on our client PCs, like whether it's the Microsoft's acquisition software, or it's some simple Jupyter notebook that you've written. All of these things, we're used to downloading the data from eLabFTW, then creating a duplicate in the process, and then running it again through an analysis, and then creating another copy of the data and re-uploading that. So it's really hard to manage and record all the mutations that were done on the data. So this is where this idea of launching other tools directly on the server came. And the added benefit is that only the person who is really designing the tool needs to manage all the dependencies and making sure it works the right way on the same system. So this really helps with reproducibility, and also it's efficient for the lab to work together. So the person designing the analysis routine doesn't have to really focus on the experiment side, while the experimentalist doesn't have to deal with compatibility issues with their operating system or packages and whatnot. And also because this runs on the same system, so if you provide a link of this experiment to the public, they can also come in, click the same tool would launch, and the analysis would be done in the same way. To demonstrate this, I have a video of an earlier version of how I implemented this with eLabFTW. The idea is that if you upload a certain file with a certain name or extension, in my case, here for Jupyter Notebooks, if it's a .ipynb file, a link to load into Jupyter Notebook shows up right below this file. And once you click it, it launches a Jupyter Notebook instance with all your experiment files in there. And if you click your ipynb file, just as you would expect, you get a running Jupyter Notebook. And if you would like to do some analysis or plot and whatnot, you can do it directly on the server. But I guess the more fancier or interesting one is the ability to launch other tools, not just Jupyter Notebooks. So we have an in-house tool called the FRWR. It's a reconstruction algorithm. And here we show how we can store the configuration JSON file. So all the parameters that we would possibly like to change could be extracted into a JSON, and the user can edit them here. And then once you click run in FRWR3 on the same configuration file, it takes all those parameters, and now you see this is a terminal window, because this is a C++ application written to be executed from the command line. It opens up in a web browser window using the Guacamole client. This is similar to what a VNC would do, where you really route the display out to another computer. So the server is providing some desktop environment that you're just viewing in your browser using remote desktop technology. And here you can see that the analysis can run directly on the server, which is much faster because the server is usually stronger. And also you don't have to sit and wait on your computer. You can just walk away, grab a coffee, and when you come back, your analysis would be done. And I have another example here of showing how we could also add other web tools. Here in this example, I'm loading Libertem on a relatively small 800 MB file, or large, where I can show how analysis could be done from another web tool directly in the browser. So this same file has been mounted into the Libertem system, and you can run all the analysis that Libertem provides. And so this brings me to the design considerations that I had. Like with all these developments, there were a few problems that I faced. In the talks yesterday, we showed how we were using our microscope acquisition software directly on the server and running analysis with that as well. But the problem with the way eLabFTW handles files is that it flattens them out in one sort of, let's call it a virtual folder, and attaches them with the experiment. The problem with that is, like, if we need some kind of folder structure to have projects, just like the microscope software would expect, we cannot recreate that unless we really change the way files are stored. The other point is that the data that we are publishing on eLabFTW is not really supported by a schema. The template is somehow defining what we're storing, but the template, because it's based on mostly rich text and some sort of fields, it limits us in our creativity of how to store data. So if we have like multiple sensors, how could we structure and list many sensors together and whatnot? So it's the user experience becomes a bit harder to manage once you have complicated instruments and devices. Another problem, well, it's not really related to any system in particular, but it's just that once I'm developing all these features or we're working on them, we have to push them back into the main project, and then someone has to maintain them. And it requires a lot of effort into making sure that the design philosophy fits with everything. And also it's useful for enough people that the original maintainers of the project would like to continue on top of that. So this is something I always had to consider. And then, as I mentioned before, like handling large files, even though I did that upload mechanism was done, it was still a problem because let's say I'm in my container, in my launch tool, and I'm creating a file. It's not that easy to really place that file back into the same experiment structure. I'll have to write a script myself and really push that through the API instead of having access to the same kind of file structure that most apps would expect. The other problem we faced was team management granularity. So in our lab, there are small groups, of course, that work mostly together on projects. And then if we have a collaboration from someone who's not part of this typical group, it's not that easy to just add someone to the group. We need an admin to create a new group or add that person to the group. Then it kind of affects the visibility of all the other experiments. And then once that person is done with that experiment, it's not that easy to remove access as well. You have to contact an admin again, and the admin has to remove it. So I have made an issue on the GitHub page where I've given some sort of example that we could work with, and maybe that will get implemented soon. And this comes like with the technical depth stuff, like there's no real plugin support. So any modifications I do have to go into the main source code. And that has been quite a bit of a barrier to provide all the functionality that I'm working on, because it's not that easy for everyone to install a custom version of a software like that. I have found a way around this, but um, it's kind of a hack, and really depends on the version of eLabFTW you're still running, but it's relatively easier than installing a completely different version of eLabFTW and maintaining that as well. And this brings me to how we are envisioning now the same workflow with NOMAD. So this is a little workflow image I like to show, where you collect data from your microscope and it gets directly uploaded to a service like NOMAD. And then you can launch different tools on this, from using Jupyter Hub's launching capabilities. And most importantly, when you have launched these different tools like this, it leaves it gives the space for a developer to really find a way to version control these analysis and create a kind of a session. So whatever you did, for example, in Libertem, could be reproduced when you come back and you say, hey, that session I did on Wednesday at 10 a.m., could you please rerun that? And then it could be launched again. But without having these launched from a central place, it's much harder to implement in every piece of software. And once this data is available, you could have collaborators from around the world accessing and running analysis on this data. So one thing that NOMAD really supports well, coming from its background in theory data, is like it accepts large data sets, and we didn't have much problem with uploading any amount of data. It also has a project structure. So we could easily upload our microscope acquisition projects, like the whole project folder, and all our data stays there. And our lab technicians and anyone who was using that software doesn't have to go through any other hoops, and it just works as they would expect on their computer. Another point here is that NOMAD really provides a very nice fast search capabilities. So they have a very cool filtering system. So once your data is collected and you have, I don't know, hundreds of different experiments on there, you could really search for every single parameter and really filter down to what you're looking for, rather than hoping that people add tags. And yeah, so this is where the structure of Nomad really helps for our lab work. And most importantly, once we have this, once we have data at the experiment level, once we're working with the project, it makes it easier to finally publish it to Nomad and make it available as part of our publication, because it's already been processed and consumed and documented in a nicer way. And this brings us to the main idea that like really aligns with what our lab wants as well, because Nomad is supporting FAIR data. It means that all the ELN capabilities also kind of lean on that FAIR idea and make sure that everything is well documented. This brings me to the end of my talk. If you have any questions from today about eLabFTW, Nomad, or from yesterday from Christoph's talk, and you would like to ask, please go ahead. And that's all from me. Thank you.
Thank you, Sherjeel. Very nice demonstration. And actually, we are now ready for the questions. There were some questions actually in the chat, which has been partially answered by Pepe. That was one question: if the fields, these extra fields defined in the JSON, if they are reachable via the API, and indeed they are. And the example provided by Sherjeel is also taking this data. And actually, that's the way that, if you may remember on yesterday initial talk from John Harris Scott, he started with highlighting that it's important that you are indeed doing data modeling work first. You really have to collect what you want to put into the system before just installing something and typing in. That's the same thing what also Pepe highlighted, that it's important things not just to put into rich text editor where you may mistype something, and then Sherjeel and others will have problem with trying to parse this information, and the parsers will all fail because they just don't find the data. But rather, you really have to use schema, and the JSON implementation in eLabFTW helps you to do that. And as soon as you've got this, then you are already one step closer to have something fair, which is findable. At least now it's also can be accessible. To be interoperable and reusable, you really have to define what they are. So it's not enough just to give a schema and that's it. You really have to define what is in the schema, because that's how people can then interpret, and then that's how people can then write code, so it becomes actually machine interpretable afterwards. And that's what also Nomad provides on the other end, that all your machine interpretable data is managed together. It's searchable, filterable, and so on. So we are ready for new questions. You can have questions also for Pepe. And I remember that Abebeji Akin Dadelo, if I'm pronouncing it right, certainly not, had a question, and maybe he wants to switch on his camera and ask the question now. I think actually we just lost the connection to him. So that means that I will let the chance to Kyung-Chan Lee to ask the question.
Thanks for the nice talk. I just want to ask you, what's like the biggest advantage of using Nomad is like it can handle the bigger data like effectively, or what's the biggest advantage of like Nomad? And
well, one, like it's many things. It's the way it's really designed. It's accepting of different file formats. In like that was the first design philosophy, I think. I mean, I'm not a Nomad expert, but this is how I see it. So it really supports versatility, and of course, we produce a lot of large data in our lab. So this is a vital part for us, that we really upload large data. So definitely a big plus. But on top of that, you also get more structure to your data. So everything that is stored has some kind of definition behind it. So this allows us to really make sure that the templates that we're creating are can be computer checked in a way. So it doesn't rely on just text in a field and the spelling of the text. It's more like this is an entity object. So let's say for someone who wants to parse this data using a computer, NOMAD makes it easier than just editing, just parsing through text, I would say. Yeah. But also maybe Marcus Scheidgen might be able to tell you a few more things on that.
Indeed, that's what I wanted also to support. The point is that the nice thing, actually, this is what FAIRmat is about, is really to manage your data in a fair way. And fair really means that you really have to store the data on a way that it is understandable, interpretable, not only just findable and accessible. So that means that it's not enough just to store your data, but also you have to know what you stored and in which way. And you may have a convention today that everything which starts with KY means something, and all the PhD students knows it today. But after they go out in 3 years' time, no one will remember what the K1 convention was, and you don't understand why this whole thing is stored like this there. And that's why we really try to push into the direction that whatever you store, you have to store it with a proper definition. And that's what FAIRmat, that's what NOMAD really supports. On the other hand, it's also clear that it is a transition. It doesn't go from one day to another, that from everything becomes well-defined, annotated. There is an ontology behind, and you know all the relationships between all the metadata items. No, this is a transition. We have to start actually with some schema defined. And this is important, that your main workflow in your lab needs to be defined. And then gradually you can increase these definitions more and more. And this is very nicely supported by NOMAD, where you can store also just text annotations in a rich text editor, exactly as you would do in eLabFTW or elsewhere. But you can really take advantage of all the metadata schema in the background.